Good morning.
Good morning.
I see you're wearing your pink polo again.
I turned them all pink.
Oh, okay. Well, maybe if you wash them a few more times, or, did you try bleach?
Yes, but I can't make them not be pink.
Oh, okay.
Good morning, Ramblers. Good morning, Ramblers. How are you guys doing? We're okay. So, I can't help but notice, you're not in uniform, young man. Pink is not a polo dress code. Well, you see, my homeschooling economics teacher wasn't so good, and she didn't tell me to separate my clothes.
I know, it's really kind of funny, right? All of his polos are pink.
Yeah, I'm sorry, sir. That's okay. It's just nice to see you back at the academy. Have a good day, Ramblers.
Dring! All right, class, it's time to get started. Everyone take a seat. Hi, Mrs. Dempsey. Hi, Mrs. Dempsey. Sorry I was late. There was a long line at the drinking fountain. Get out of my way. All right. I am ready to learn today. Well, I'm glad you guys are ready to learn today. So, what we are going to talk about today is we are going to be talking about the law of logs. So, I know math sometimes feels like a prison, but really? Laws? Well, yes, we have laws. They're just like rules. So, we're going to start taking a look at these laws. And in order for you guys to do this, I need you all to take out your calculators. I've got mine.
Let me look at my bag. I think my sister took it.
Oh, mister.
As long as you remember to bring your calculator.
Well, I guess you guys are just going to need to know what some of these are without your calculator. So, let's move on and let's start taking... Wow, that is one large calculator that you got there, student A.
Yeah.
Yeah, my dad said I lose things if it's not attached to my head. And so when he saw they had this super duper giant calculator, he got it for me because he thought if it was bigger and pink that I wouldn't lose it. And look it, I still have it. All right, so let's keep going. So what we're going to be looking at today is we're going to be looking at our law of logs. Now, we started to look at how to evaluate logs. What does it mean to be a log? And so we know that when we look at this first example, it says 6 to what power is in fact 4? Well, can I write 4 as a power of 6? No. So the only way for me to be able to evaluate these would be able to use my calculator. And so if we take a look here, if I was going to use my calculator, whoa, I went all calculus on y'all. What we're going to end up having is log base 6 of 4 plus, and it's also easier to arrow up rather than down, and look at we get 2. And so even though I don't know what log base 6 of 4 is, and I don't know what log base 6 of 9 is, I can't rewrite those as powers of 6, I still get this nice neat answer of 2. Well, why is that? Like, what is going on here? And so we're going to look at that, but we're going to do one more example here. So again, now I have log base 10 of 5. Well, 5 to what, or pardon me, 10 to what power would get you to 5? Yep, don't know. 10 to what power would get you to 20? Again, don't really know. Now, one thing that I want you guys to see, though, is that you guys are looking at a common logarithm right now. You won't typically see me ever write this 10 here. It is your common log. So we don't need to go in and hit that math button. All I need is this log button. Because when I hit this one, it's already assuming it is base 10. You won't see a little subscript there, but it's there. So we end up with log of 5 plus log of 20. Oh, and I got 2. Now, it just is coincidence that they're both actually 2, but it is not coincidence that they are both nice whole number answers. Because what's happening in these problems is this law of logs that I'm going to write down here is getting applied. And so what your law of logs, this is our first one, says is that if I have log base b of x plus log base b of y, I can condense that to a single logarithm, and I have the log now of the product.
What time? I don't know. To see my thought.
Like 20 more minutes, okay? Joey's upset. She wants to see her class. Okay, I can show you my class, Joey. Hey, you want to be in my class?
What about mine? We're fun. We've got a giant calculator.
And she's off to the races. See, no one wants to do math in my house. All right, so we end up with log base 6. We can only do this when they have the same base. And I can write it as a single log, but I need to multiply the 4 and the 9. So log base 6 of 36. Well, we've seen this. 6 to what power gets us to 36? And that answer is 2. Well, let's look at the same thing here. Log base 10 of 5, or log of 5 as we would say it, because we can assume the 10, plus log base 10 of 20 would equal log of 100. But we know that if it's a common log, we've got that base. And again, now it's 10 to what power, because it was the 5 times 20, gets us to 100. And that is 2. So this is the expanded form. And this is your condensed form. It's condensed because it has one log, a single logarithm. Okay, welcome back to class. I had to take a quick break there. The dog wanted to go out. Okay, so now we have this next example. And so when we start to take a look at this next example and we plug it into our calculators, now, if you don't have your calculators, by the way, there's a lot of online calculators that are free right now. So, like, if you go to the TI website and stuff, you'd probably be able to get something for free that will be more temporary, but would probably do the trick. Okay, so now I've typed in my log base 4 of 100 minus log base 4 of 25. And we got 1. Well, what's happening here when we have the difference of two logs? When we have, the other way I like to think about this is, when we have the logs that are getting subtracted, the logs become a fraction. So, the log base 4 of 100 over 25. Well, 100 over 25 is 4. Log base 4 of 4 is 1. So this next one is log base b of x over y. The subtraction of logs becomes the log of a fraction. The subtraction of logs becomes the log of a fraction. Now notice there's only one log base b here. When you are condensing to a single log. You should only see log base b written one time. Single means one time. Now, this again is the condensed form, and this is what we would refer to as the expanded form. And this is our second law of logs. Now, this next one, you're like, okay, there's more? Yeah, there's more, but this next one you kind of already do in a weird way. So right now I have log base 3 of 9. Well, when we first started this, we looked at the fact that I could rewrite 9 so it has a base of 3. So an equivalent expression here is log base 3 of 3 squared. Well, there were some properties of logs that we went through the other week, day, whatever. Here they are. See them? Pause them. Write it down if you need to. But if you guys take a look at rule number 3, log base b of b to the x equals x. Well, this is an application of log base 3. We know that this is going to end up being 2. So this next law of logs is going to kind of explain a little bit about how that works. Now, what I want you guys to see here is in this next rule, you can write this one down, the next law, is that if I have a coefficient, that coefficient can come back as the exponent. But it also can go from the exponent to the coefficient if we're going the other way. So if I take this 2 here and I move it in front, I have 2 log base 3 of 3. Well, what is log base 3 of 3? When these match, remember, you guys are supposed to know these. So when those match, someone's gone crazy in math class. When those match, that is 1. 3 to what power gives you 3? It's 1. So this is 2 times. Oh no! Calm down. Calm down or I'm going to give you a drug. Mrs. Dempsey, do you need any help in here? It's getting a little loud. Yeah! But we're quarantined.
No way!
So, I'm going to give you a few examples of expanding and condensing next, but these are your 3 laws of logs you need to know. All right? So, if you're a note taker, you should take notes. All of you should be note takers at this point. You should have this one written. You should have this one written. And this one. As well as those already. Okay, so let's take a look at some of these examples in which we're going to apply those 3 different law of logs that I looked at with you. So we're going to be expanding it completely and evaluating it when possible. So right now, each of these is a single log. So we're going to work on expanding these because I think it's easier to expand than it is to condense. So we're going to start with that. So right now I have log base 5 of x squared over 25. Well, right now I have the log of a fraction. Well, the log of a fraction turns into subtraction. The log of a fraction turns into subtraction. And it's always what's on the bottom that's going to be getting subtracted. So I'm going to have log base 5 of x squared minus log base 5 of 25. So right here I can see that I have this exponent there. If I am expanding, I don't want exponents. Those exponents have to move and become a coefficient. So I have 2 log base 5 of x minus Well, do you guys see here where it says evaluate when possible? Well, can we evaluate log base 5 of 25? Do we know what that equals?
No!
Oh, Joey made a puppet for me. Oh my god, that's awesome, Jojo! All right, so...
I would attach some tape right there so you make the little wet.
Okay, thank you.
And I touch
Oh, thanks. Good job. Oh, kisses. All right, log base 5 of...
I'm white.
Oh, log base 5 of 25. 5 to what power? She's the sweetest thing. 5 to what power gets you to 25? 2. So, this is the completely expanded form. All right, well, now we get to this. Well, here, I want you guys to really pay attention. Now we have log of m times log of... Listen, I need you to quiet down right now. I'm trying to teach and your classmates are trying to learn.
Don't tell me.
So,
No way.
no way, no way. Do students talk back to Mrs. Dempsey like that?
All
right.
Go.
No, they don't. All right. So, we have log. We're going to expand this. I need a second, Joey, please. We have multiplication going on here. So then I end up with log of m plus... Oh, now she's... Oh, you hear that? I'm a horrible mom, and she's having a terrible, rough day. Me too. All right, so this is the last thing I want to look at for this problem. If you have the square root, that's actually an exponent. And so what you guys have there is log of n to the 1/2. So you're going to take this 1/2 and you're going to move it, but just in front of this one, because the only thing that square root's taking the square root of is the n. So your final answer here is log of m plus 1/2 log of n. All right, and I'm going to do one more, and then I'm going to take care of my children. I thought we were your children. Yeah, Mrs. Dempsey, you always call us your kids. I'm going to take care of the kids I'm quarantined with. Or sheltered in place with. Okay, so here, I want you to notice we have the 8, the x to the 5th, and the y to the 4th. So, these become, I'm going to first take care of that fraction. So remember, the log of a fraction turns into, you bet, subtraction, minus log base 2 of y to the 4th. Well, there's a few things that I can notice I can do here. I know that I've got that 4 there, so that's going to get moved to that coefficient. And here now, though, I can still separate these. I've got the 8 and the times x to the 5th. So this is going to get separated with addition. So I get log base 2 of 8 plus log base 2 of x to the 5th minus, and remember I'm going to move that guy, 4 log base 2 of y. Well, log base 2 of 8, hopefully you guys know at this point is 3. That coefficient, that's going to become the coefficient. And that is our fully expanded answer. So I'm going to give you guys a few problems to work on for homework. But these are the 3 rules that you guys need to know. And if somebody could create me where I don't look like a bug, that'd be cool. And student A, hi guys, I need a name. Yeah, I think I do too. If you could send me some name suggestions, and please, a puppet. Bye everyone. I hope you guys are doing okay.